Hey Calc kids, welcome to the spring break edition of videos. Hooray! Hooray. Okay. Alright, we're gonna look at 25. This video, if you're one of the people who watch this who are not in my class, will make no sense at all. I'm going on a review sheet. I don't think I can publish it. I think it's copyrighted by the book company, so I'm just gonna put down some work for the yahoos. In 25, they give you y is cosine of 3t, and x is sine of 3t, right? Hold on, I gotta pause this piece. Okay, and our end result, we want our dy over dx, right? We want our derivative of that function. Okay, so first what we do is you find your dy over dt and your dx over dt. So this beast, using your chain rule, 3 comes out in front. Oops, sine of 3t. This is going to be negative. It's negative because derivative cosine is negative sine. Then your dx over dt is going to be, again, 3 comes out in front due to chain rule, cosine of 3t, right? Now to find dy over dx, you take your dy over dt, you divide it by your dx over dt, and your dt's will end up canceling and you get your dy over dx. So your negative 3 sine of 3t divided by 3 cosine of 3t. 3's cancel. Okay, so that's our derivative, right? Right. Okay, now to find the slope at that point, we have to plug in that, not pi over 3. I didn't write down, what was it? 9 pi over 3, 2 pi over 6 pi over 3. Oh man, whatever, you just plug in that, your t value. I should probably go look that up. Nah. Why not? Okay. Oh, it was 2 pi over 9. Right? So you plug in your 2 pi over 9 into each of these. Right? So it's negative sine of, well, cancel, you get 2 pi over 3. And you're plugging that into that equation. Over cosine of 2 pi over 3. Again, you're just plugging it in for t. Right? And according to your unit circle, sine of 2 pi over 3, if you forget, you're right here, right? 2 pi over 3 would be, what is that, 1/2, square root of 3 over 2. All over cosine of that is negative 1/2, right? So if you simplify this beast, you just get a positive root 3, which is your slope at that point. So then we do our point slope form. Y minus something equals your slope, x minus your x point. We'll define your x and your y point. For your y point, you plug in your t to your y equation. But wait a second, we already kind of did that right here, didn't we? So you get y minus 1/2, right? Square root of 3. And then you get x minus root 3 over 2. Right. By the way, this would be a plus because it's minus a negative. You multiply that square root of 3 over, you get square root of 3x minus 3/2. You subtract a 1/2 from both sides. You get y equals square root of 3x minus 2. Ta-da! The end. That's all there was to it. Let's do some. Alright, for the next problem, I'm not going to go through like A, B, C, and D. I'm just going to go through and tell you what I figured out and how. I'll let you guys figure it out from there. Okay, so for this one, we're looking at an equation, and we have to find out where it's increasing, decreasing, maxes, mins, concave up, concave down, all that good jazz, right? Okay, hold on. Okay, so we're looking at the function x to the third minus 2x squared plus x, right? First thing I want to do, if I'm looking at this beast, or I'm sorry, I already took the derivative. This is your first derivative. I'm just looking at my jumbled work here. So I need to take the first derivative to determine where I'm increasing, decreasing, and all that good jazz. So first I set that equals 0. I have with x equals 0 and 1. You factor out, and I did that, use factor out x. Right? Oop. And then that factors pretty easily into x minus 1 squared. So you have 0 and 1. And then you do your good old wiggle graph, right? 0 and 1. You plug in negative a billion into your derivative, you get, well, you get a negative. If you plug in 0.5 to your derivative, you get 0.5 times negative squared, so it's positive. So a positive times a positive. If you plug in a positive billion, you get positive. So this is where you're increasing, because you're positive. This is where you're decreasing. Oh no, my computer just can't handle this ferociousness of this mathematics in which we are doing. Aren't you enthralled? Okay. So now for maxes and mins, a max is when you go from positive to negative, you get a max, right? That doesn't happen here. When you go from negative to positive, you end up with a min. Because you're going down and then you come up and then you come down, right? Max in the upside down frowning face, min is a happy face. Okay, so this would probably be where a min would occur at. Okay, if you want the actual min value, you have to plug a 0 into your original equation. Okay, let's switch up colors here for a second. So now for concavities, you're going to be looking at the second derivative. Second derivative is 3x squared minus 4x plus 1. You set that equals 0. Luckily, it factors out very nicely into 3x minus 1, x minus 1. Guys, if you aren't good at factoring, you should brush up on it. Just because it's good for you. Whoa, crooked line. That's fine, we'll just be crooked people. So your zeros are at 1/3 and 1, and you wiggle graph it, and you plug it into your second derivative. You plug in 0, you get negative times a negative, which is a positive. If you plug in a half, you get, what's that, negative and a positive? Yep. Negative times positive is a negative. And you plug in a bazillion, you get a positive. Positives all around. So now, you are concave down, right here, and you're up here and here. Okay? Concave up where you're positive, concave down where you're negative. Inflection points are any point you change concavity. So from positive to negative. So these are your IFs. Okay? Again, I'm not giving you the straight up answer, I'm just telling you how you would find it very easily and quickly. I did the factoring for you. What else do you want? What do you want from me? Okay? Oh, 38 is a doozy do. First, let's look at A. So you have a box, see? The volume of that box is x times y times z. Length times height times width, whatever order you want. So we need to find b prime, right? To find out what to do with those points in which we're given the dz, the dy, and the dx. So we get, oop, sorry, I can't do that yet. So I'm going to use the product rule. I'm going to say u is xy, v is z. So u prime, v prime. V prime is just dz over dt, right? U prime, though, we have to do a sidebar. So we're going to have to do u is x and v is y. So we have to do a product rule in our product rule to find out the derivative. So u prime is x. Ooh. Getting old, guys. Dx over dt. V prime is dy over dt. Right? I'm going to use primes for the rest of this, so just deal with it. So you get x y prime plus y x prime. So that's our u prime, right? So we cross multiply once more. So you have to times this whole mess by z. So you get z x y prime plus z y x prime plus x y z prime. You see a pattern there? You get everyone's derivative once, and it's all the different pairs that could be possible. Don't be surprised if you don't see one like this on the good old app test. Then you just plug in your numbers, you know. Oh, I did this in completely different order. Well, y prime is 0, so this whole thing is 0, right? Plus z, y, x, so that would be 4 times 5 times 8 plus, this is going to be 10 times 8 times negative 3. And when you multiply that out, you end up with negative 80, and that's going to be feet cubed per second, because we're volume, right? Yeah, we are. Check. Okay. Now let's take a look at B. Okay. So for this one, we're looking at, what is it, surface area, right? So our original equation is 2xy plus 2yz plus 2xz. Okay. I'm going to take a shortcut here, guys. I'm going to pull 2 out. Now your derivative of xy, let's take a look at this. Do you see when you take the derivative using the chain rule, you always get, you know, x times derivative of y times derivative of x? I'm going to use that to my advantage. So this is going to be x prime y plus y prime x plus y prime z plus z prime y plus x prime z plus z prime x. You guys can't see what I did there? And then all your y primes are equal to 0, right? So get out of here. Get out of here, you jerk. Okay? And then you just plug it in. So here's 4 times 8, right? Don't need parentheses. Plus, oh, I did this all out of order from what I once did. I don't even have that one written down. Anyway, you plug in your values that are given to you on the sheet, and you end up with negative 4 feet squared per second. Oh, Lordy. And C. Oh, Jimmy Crickets. C is actually not too bad. C is actually probably the easiest derivative. So first thing I do is I take this and I make it so it looks like something I can do something with. I put that to the 1/2. You take derivative, you bring the 1/2 out in front. Subtract 1 from your exponent. Times it by the derivative of your inside, which would be 2x prime, chain rule, implicit, 2y prime, 2z prime. And then you just plug in your numbers once more. Well, I know y prime 0. I have a bunch of other work there. Remember that negative means this is going to go to the bottom. Right? All times 1/2. When you plug that in, you end up with 50 over root 189, which is about 1.818 feet per second. Because again, we're just in one dimension now. We're one-dimensional people.